this.
This heckling brought to you by.
I'm gonna hold it to my lip. Oh,
There
that
you
is
go.
loud.
Eat it.
All right, I'm gonna hold it a little away from my lip.
No. What'd you talk about?
So, yes, thank you, Dickie.
You did badge.
I did, yeah.
Continue.
So, my name's Tyler. I'm one of the folks who. Thanks, Tyler. Thanks.
Yes.
I know there's a couple of us here, so you might, yeah. They're everywhere. They're all around you. Don't blink.
Infested. Teeming with Tyler.
Right. But I'm one of the folks who helped put together the badge for Freaknik this year. We ran through some troubles and stuff, but hopefully we're starting to get those worked out. And I'm going to be sharing some of the behind the scenes hacking of the electronic shelf labels that go inside the badge, as well as some of the kind of fun specifics about the badge itself and how we put it together and what the software is that's running on it. I'm hoping by the end of this you'll have at least the inspiration and maybe a little bit of the knowledge to go play with it on your own. I'll share some of the source code and stuff for the firmware, and then you'll probably start seeing these labels everywhere if you don't already do, and you'll be like, I wonder if they're gonna miss this if I just pull this off the shelf. So, if you don't know what electronic shelf labels are, you might have seen them in stores around town. They come in a bunch of different shapes and sizes, but in general, they're designed to allow store workers to dynamically and efficiently update labels, prices, sales, clearance on the shelves instead of having to print out new labels and stickers and put them on the on the shelves themselves. I don't really know what drives a company to decide to do this, what the cost benefit analysis is, but you'll see it even at grocery stores. We were talking about Aldi, or they have them at Aldi. You'll see them at Best Buy, so it doesn't necessarily mean it's a cost thing. Expensive stuff has them. You can get them on cheap groceries and stuff too. They have different mechanisms they use to update the image on the tag itself. Some of them use NFC, some of them use infrared. These that we have in the badges use this sub-gigahertz radio. So I think these are set up for 915 megahertz. They use a Zigbee or 802.15.4 kind of protocol to do that. And then there's usually an ultra low power display on them. Some of them are ink or e-paper. Some of them are just really low power LCDs. So the ones in the badges are a little bit different than e-paper. You probably noticed they don't kind of look like paper like e-paper or e-ink does, but they're a really low power LCD. And so a lot of these labels, they use these non-rechargeable coin cell lithium batteries, and you can get a lot of time off of those batteries, even though they're small and one time. But some of these don't even have a way to replace the batteries. They're just kind of welded in, and you use the tag for a couple of years, and then you throw the tag out and get a new one. It seems like that doesn't make it worth it if you're replacing something that's replacing you having to replace things, so kind of silly, but I don't know, I guess it's worth it. But that is a fortunate thing for us, because that means they end up on eBay, or they end up in the trash, or they fall off of trucks. I don't know what the physics are around that, but things fall off the trucks a lot. I don't know how that happens. It's kind of weird, but this is actually an eBay listing for the shelf labels that I bought for the badges themselves. For reference, they're pretty cheap because these have those batteries that you can't remove. They're basically useless. They're e-waste. So yeah, this listing was you can get 100 of them for $66.49 plus taxes and stuff. I'm not a mathematician, but I think that comes out to about 6-7 dimes each.
6, 7.
Had to do
Sorry,
it.
I wasn't paying attention.
Had to make the kids groan. I've done that so much that it's become my personality. I hate it. It's awful. No. Also, if you notice up here on the top, it says there's no battery. That's not true. The batteries are dead. They're in there. They're just dead. And so we now have 400 of these batteries we have to go recycle because they contain lithium and you can't throw them in the trash and all that stuff. So, when I was looking to buy these, I don't think I would have been very excited to play with them if I didn't have like a jump start on like some of the work done to like put your own code on here and like figure out what the display technology is and what the protocols are and all that kind of stuff. So I heavily relied on the work by Dmitry Grinberg, whose name might be familiar if you're like a DEF CON folk from a couple of years ago, or maybe it was last year, I guess 2 years ago, the badge. He did the firmware for the cat-shaped RPi, the new RPi microcontroller. But he had already done like a bunch of like the reverse engineering work on a whole bunch of different shelf labels, including the EPOP 50 and the EPOP 900, which is super similar to the EPOP 55 that's in the badges. So I felt confident. I was like, okay, this is close enough. I'll at least be able to use the same display, at least be able to use the same programmers and do all that kind of stuff. So I bought 400 of them off of eBay. Now I have giant boxes of these tags. The next thing you have to do is you have to get it open. I was hoping that they would have the replaceable batteries, so you could like open up the back, and then you can pull the batteries out, and sometimes that exposes the programming pins. No such luck on these. These are like glued shut, or maybe they're like ultrasonic welded or something. They're kind of a pain to get into. This is the best way I found to get into these. Is to take like a pair of like flush cutters and snips, kind of break just like one part of the little like plastic bezel, and then like once it's snipped, you can usually kind of like pry open the rest. So like that one got like most of it off. It's probably gonna, this one breaks right there on the barcode. So it's like you almost had it, and then yep, okay, all right. So you gotta,
I haven't heckled in a while.
For all 200 badges?
we did this for all 200 of the badges. Yeah, we had to. So huge shout out to Mog and Mog's wife Heather for doing most of those. I did like probably a tenth of what they did, maybe less, but yeah, it's not too bad. Like I think this video is like 1:30, so like you can go through 200 a couple of hours watching a
Prove that
TV
those
show.
are your hands.
I recorded this in the hotel like 30, maybe an hour ago. So yeah, that's a Clarion desktop right there. Like,
Oh, I might have been there for that.
I think you were in the bathroom. Yeah.
Oh,
Yes,
okay.
you were.
Okay.
I had no idea you were.
So you can replace the batteries?
So unfortunately, well, you probably can. The batteries themselves are also welded to each other, and so it's like you can pull them out, and so like you have to, I don't know, it's a pain. You could theoretically do it. There's no way that case is going back together the way it came, so you'd have to print a new case or something. But yeah.
So wait.
Oh, no, I'm sorry. Continue.
All right. I was like, all right, no, Dickie asked me to wait. I'll give you 60 seconds. Yeah.
He's had quite a lot of
We're gonna take a recess.
So once you get it open, there's actually not too much in there. You've got the microcontroller that's sort of running everything. You've got the CC1110. It's based on the Intel 8051 microcontroller architecture, and it's got like a sub-gigahertz radio stuck onto it. I think the radio is the CC1011 or something like that. It's really annoying when you're Googling, trying to like keep these in track. But the wireless runs the board, handles the wireless communication, or sorry, the microcontroller handles all that. You do have the 2 coin cell batteries you saw when we were pulling it apart. According to ZBD, which is the manufacturer, or their old name, they're called, I think, Price Display or something now, Price Data, I think. But according to their sales sheet, they should keep the tag alive for like 10 years, which does kind of match up with when I got these on eBay. Because if you look at the PCB, it's got markings for like 2013, 2014, and I picked them up, in 2025. So 10 years, maybe a little bit more, then they toss them out. And so right now is a pretty good spot to get these particular badges. The exciting part for me is the display. So it's got this.
I'm very excited too.
Yeah, it's got this like bistable LCD display. It's kind of like e-ink or e-paper. Kind of mentioned that. It's got a bunch of similar characteristics. whenever you burn an image or whenever you display an image on there and remove power, the image stays on there. So that's the bistable part of the LCD. It refreshes a lot faster than e-ink technology of 15 years ago when they were developed, and makes it like pretty neat to be able to like update in real time instead of like waiting the multiple seconds that it took e-ink to like update an image before. Another neat thing is it's got like a reflective backing on here. If you look at Dimitri's website, you can see where he's like peeled off the reflective backing, and you can actually see through it, just like you do with an LCD where you've removed like the reflective or like LED backing. Mog has one, I don't know if he brought it, but he put like an EL panel behind the display, so it like lights up and it looks like an old like Nokia phone. Pretty cool. But yeah, it's pretty neat technology as far as like 15-year-old like display technology goes. So the next part is programming this thing. So there's a couple of different like compilers and tool chains you can use to program for the 8051 architecture. TI has their IAR workstation, workbench for 8051. You can get the Keel compiler. That's adult money. Like that's like $5,000 a seat for a year. I'm not. Like I said, they're 60 cents a piece. Like I'm not buying a compiler for that. So what I used was the SDCC, the Small Device C compiler. It's a GNU licensed free open source compiler. It's got some quirks. It's not the most efficient thing in the world. It doesn't do the best optimizations, and it does some like weird things to your code sometimes, but generally gets the job done. You can always break out into assembly if you have like a weird compiler optimization thing you want to make or avoid. You'll also need like a hardware programmer, so I have the CC debugger on here, and that's just like a thing provided by Texas Instruments. They're like $15 on Amazon, so I picked one of those up and used it to flash, and that worked well enough. I used it on Linux and Mac OS. I assume it will work on Windows too, because TI always targets Windows for all their stuff. And then I ordered a bunch of them off of AliExpress so I could bring them to the con so that people could play with them and like hack their own badges and stuff, and none of those worked. Kind of unsurprising sometimes, but it was a little disappointing. They had like an old Rev PCB in there, and I like looked up some information online, and it said like that that particular Rev had a particular bug with a very specific iteration of the silicon on some of their microcontrollers. And I'm like looking up the model of the silicon on the microcontroller, and I'm like, yep, it's that one. So it probably just got really unlucky with the board and the programmers themselves. But if you like pick one up for like $15 on Amazon, it should work just fine. It's quick and easy. But the other option is to use something a little bit more modern. So this is a project made by, I think his name is Aaron Christoffel, if I'm saying that right. He put together this like Arduino program that lets you flash the CC1110 like and a couple other CC family microcontrollers using the ESP Wi-Fi microcontroller. I can never get enough of the ESP in my life. I have buckets full of them in various places tucked around my house, and so if I just open a drawer, there's probably an ESP next to the knives and forks in the kitchen, and just keep them everywhere. Again, Mog helped me here. He pointed out this project and like proved that it worked, and so I put away my CC debugger until the con because I ran into some flaky things with the ESP. So I had mostly used it pretty exclusively, but the neat thing about using an ESP as your programmer is that you can add a lot more sort of like fun capabilities. So one of the things we wanted to do was use it like to make these like little programming stations you'd like bring your badge to, set it down, it would go like fetch your latest image that you've configured, automatically flash it. It's a little bit harder to do with the CC debugger because you need some sort of like USB host kind of device, like you'd have to have like a Pi or something like that, but it was gonna be really nice. But I won't dig into that too much because we had issues, so I might talk about that afterward. So I'm gonna kind of change gears into like the badge specific part of this. So why would we use this for a badge over something else? Especially if we're having to like kind of like reverse engineer parts of it or deal with hardware limitations that we don't have any control over. The biggest reason money. They're cheap. You can't get like bare PCBs printed anymore for like less than like $1 a piece at like this like 3x4" kind of size, just with like shipping and taxes and tariffs and all that kind of stuff. And that's not including any of the parts or like the assembly or your failed prototypes where you mess something up and you have to order it again and again. And also the hardware's like just done for you. So maybe you have restrictions on like what you can do with the hardware, but you don't have to worry about writing a display driver. You don't have to worry about power management chips. You don't have to worry about setting up pogo pins so you can program it. Like it's all kind of done for you. It's got the wireless antenna already like tuned and traced out on the PCB and everything, so you don't have to deal with that. Wireless is just demon magic to me, so like I don't know. I don't want to deal with like running antennas. Speaking of power, batteries alone eat up a lot of your like time and power budget on like electronic circuit boards. We opted for like a batteryless badge, so these badges don't have any batteries in them, which means you don't need to buy a bunch of batteries. You don't have to build a firmware that's power efficient, and you don't have to like spend time testing it, making sure that it's going to last the couple of days for the con. Also, like it's kind of nice that you can keep it from like going to the trash. Like we were able to give the tags a second life, and bring them back up and reuse them and keep them from going into the trash. But also, when you get home after Freaknik and you go and you throw this in a drawer and you pull it out maybe like a year or two later and you're like, oh yeah, that thing is so neat. You don't just like press a button and be like, oh, the battery's dead. Okay, I guess I won't do whatever I was, the 5 seconds of joy I was gonna have out of playing with it again. It still has your name on it. I don't know what the like time is, but like the tags I bought still had like old like Kohl's deals and discounts like on the badges themselves. So we actually have a couple of them that the display cable ripped, and so now they will permanently always have 50 cents off of the whatever was on sale at the time. That's to say nothing to speak against like building your own sort of badges. I do that all the time. I maybe just got kind of tired of using circular LCD colored displays with backlights for projects. Probably not. I'm gonna use those things till I die. Like those are so fun, and so my next badge will probably have a little circular display on there, like I always do. But yeah. So this was the idea of how the badge would work. It's not too different from that now that we had like an emergency like reshuffling of how it works last night. But the idea is that you place the badge on like a little programmer. It sends out its MAC address over serial to the ESP. The ESP takes that, hits our API backend on the internet, and says like, hey, can you give me your like latest firmware that you want me to flash? The API responds back with the firmware as well as the hash of the image that's inside that firmware, and then the ESP uses that to program the badge.
Boof,
Pretty
boof.
Boof boof, yes. And eat foots. For the MAC address. I thought y'all appreciate that one. And this worked. We had like a demo for the Freaknik people, I think last Sunday, where we like put it on the thing, it flashed perfectly, and everything went well. But we ran into some issues last night with like the ESP, like whenever you put the programmer on the board, if the pins weren't just aligned properly, like some things would short out, and we got like ESPs that got like weirdly corrupted and stuff. So we have like a different plan that I'll talk about at the end, so we can like program those for all of y'all after this. You might have a question there though. You said it asked for a firmware file for each badge. So like, am I building a firmware for every single badge and every single image that someone's putting on the badge? Yes. Well, kinda. So the way it works is we have a base firmware that has this magic string, and then some binary 1-bit data for the image, and then like another magic string, and that's what's flashed to every badge. Then we have a Python script that runs in the background, the backend that like Nathan wrote, that replaces, it like opens up that base image, replaces the bits between the two magic strings, and then puts the new image in and gives you a new like patched firmware. So I imagine this is similar to like what like ROM patching does. I don't know, I'd have to ask Key how that goes, but and then that gets sent out and stored in the database, and then we pull those down for each badge. So we do have a different firmware for each badge. It's kind of neat. You could do like firmware updates through this as well. It's not the most optimal thing. I would much rather have like something, sending messages over serial to like update just the image part. It would be faster. Right now you have a risk of like if you interrupt the firmware update halfway through, then you have like a half firmware on your badge and stuff like that. So not the best thing, but there were just a couple of problems and we just didn't have enough time to get around to like making that a little bit more robust. Some other bits and ends that you should totally come and ask about, either me or Nathan or Mog or someone. They'll probably direct you to me and I'll probably direct you to them. No, I'm just kidding. I'm happy to talk about any part of it. We did get some PCBs made for like programming jigs. So you can see this in the top right. It's got like these little pogo pins so that we can have like these like programming sort of modules. Also made PCBs that you could like hardwire. This bottom right one, this little like flex PCB. So if you wanted to have something that was like always hooked up to like an ESP or to a computer or something like that, you could have this sort of like hardwired kind of like shim board on there as well. We have the 3D CAD files for all the plastic. So Mog put that together so you can like print out your own like pager badge. I know a couple of people shared that a little earlier, and so I think we have a couple of like rare, one-of-a-kind, custom printed parts laying around. Appreciate Mog for putting all that together and letting his printer just cook itself for like 3 weeks straight, just like printing part after part after part after part. So, and then also the badge website itself. So if you scan the QR code on the back, it'll take you to the badge website where you can like configure which image you want to display, your name, the size. You can drag the like little like text around and stuff, get it exactly how you want and hit save. Nathan put that together. So yeah, shout out to Nathan for putting all that together. If there's any like bugs or security holes in that software, take it to Nathan. That's between him and Claude. But yeah, we'll put up the source code. I'll ask Nathan to make a change to like put a link on the badge site itself, so you can like get to all of the different resources I talked about. We'll have Dimitri's thing on there. We'll have Aaron Christopher's thing on there, and then the source code on the badge. But yeah, I think that's all I've got for the badge stuff. After this, we'll do questions too. After this, come find me if you want to like update your image. Go ahead and scan the QR code on the back and like get your image ready and hit save. Then you can bring it to me and I'll scan it with a little Bluetooth scanner. I'll program it and you can put your name on there. It's not going to be as cool as like we wanted it, where you could like put it on a little pedestal and like program it yourself and do all that kind of stuff. But it'll at least have your name and you can kind of take it home and it'll always have a little remnant of the Freaknik you went to. So, Ben.
What it's supposed to take. Would it be possible when applying a constant source of power, could you have a GIF or a mobile picture?
Gotcha. Yeah. So Ben was asking like how frequently can you like update the screen? Could you do like a video or an animation? Yeah. It's fast, but not that fast, and it does like blank the whole screen. It actually depends on temperature. So these LCDs are like kind of interesting. Is that like if it's colder, you have to flash it slower, and like harder. Like you have to like spend more time like flashing the pixels on it. So it does have like a little temperature sensor on the back of the screen that like automatically compensates for it being cold and slows down the thing. But when you do flash it, you'll see it go like zoom, zoom. So it's like, I don't know, I want to say like 250 milliseconds or something. So probably not fast enough to do like an animation, especially because it's updating the whole screen across. But you could like have it like, if you wanted a clock, you could probably update it every second and get a new time on there, for example. Nathan.
Do you have access to the temperature sensor?
Yeah, so the firmware does like read the temperature sensor, so you can adjust the firmware and have it like, use it as your like little weather station or something like that if you wanted to do it that way. There's not a whole lot of other sensors on here. There's an EEPROM that stores the MAC address, There's some space in that EEPROM if you want to like store other kind of data. It's got the temperature sensor. It's got like an analog sensor for like doing battery measurement. It's just my screen going to sleep. But other than that, like not much. Like no accelerometers or other like fancy little sensors. Yeah.
Is there a way, the temperature sensor, is the badge able to report back the temperature of various aisles in a supermarket or something, and can they use that data to then adjust their air conditioning or heating?
Yeah, probably. So Joe's question was, can you use that temperature sensor like at the supermarket when they have these tags to like report out the temperature at different like areas of the market or warehouse to like, you know, keep track of the temperature across your whole store? You probably can. I don't know how accurate the temperature sensor is. Like it's probably good enough to make sure that you can like properly flash the display. I don't know if it's like precise enough to like determine like a few degrees here and there or whatever. But yeah, go ahead.
Can the badges communicate back to the data center?
Yes, so they do have wireless radios in them. We're not really using them for anything like that in the badge right now.
Why not?
Because it's hard, and I didn't have enough time. I know, yeah.
Okay.
But yeah, bring it back next year. Maybe we'll have a fun custom firmware, and maybe someone hacks on that as a project. But it yeah, it does have like a little 802.15.4 sub-gigahertz radio in it. So that's generally how they work. Is they have like a base station, and they all check in and say like, hey, do you have a new firmware or a new image for me? And then it like reports back, and that's kind of how it works. I don't think they would do any sort of like meshing out of the box or anything like that. So probably has to be within range of the base station. But the code's available, and you can use the radio however you want. It's got really nice low level control of the actual like radio in the chip.
God damn it.
I know you're disappointed about that, Dick.
I'm sorry, I dropped. No, this is
trying to break.
This is incredible.
Thank you.
And thank you.
Thank you.
Is Mog here?
Hey, thanks, Mog.